1962. A hastily abandoned Soviet station sits marooned on the polar plain. Its antennas frozen stiff, its machinery half-sunk, everything left behind for the Arctic to swallow. Too far inland for a ship, too icy for a runway, too remote for a helicopter. It's unreachable. But the CIA wants those secrets. Now, a few yards away from the collapsing station, two near-frozen volunteers hold a strange stance. They crouch, knees flexed, and boots biting the floe. Each one is clipped into a harness that sends a nylon tether rising from their chests and disappearing into the clouds above. Then the hum of engines breaks the air. A shape pushes through the haze. A B-17, with two scissor-like horns jutting from its nose, lines up with the strange silver object at the end of the tether. The men brace as the line snaps tight. The ride is here. During the Cold War, knowledge was leverage. A single intercepted transmission or a few numbers jotted in a weather log could shift how two superpowers measured each other's strength. Amid this contest, the Arctic became one of the most remote yet vital frontiers. In 1937, the Soviet Union launched its first drifting ice station, North Pole 1, a few hundred miles from the pole. Officially, it was a scientific mission to chart winds, currents, and magnetic fields. However, it was also a declaration that socialism could prevail where capitalism had yet to reach. Under the direction of explorer Otto Schmidt, 4 men were dropped onto a single ice floe. For 9 months, they drifted through storms and polar night, taking measurements and sending reports back to Moscow. When the ice finally cracked apart near Greenland, they were rescued and welcomed home as heroes. Once it was proven that the station could survive while moving with the sea, the Soviets expanded the program with NP2, NP3, NP4, and beyond. By the 1950s, these bases were larger, better equipped, and increasingly secretive. In Washington and London, unease grew. Soviet scientists had once proudly announced the positions of their drifting stations, but over time, the reports grew vague and then stopped altogether. From high above the polar ice, reconnaissance crews occasionally glimpsed small clusters of huts and antennas, isolated outposts sliding slowly with the floes. Radio operators in Alaska and Greenland sometimes caught faint, coded transmissions that seemed to drift with the ice. Western analysts suspected they were not weather stations at all, but listening posts. If true, it meant the Soviets were listening for what the West most needed to keep silent: nuclear submarines hidden beneath the ice, the backbone of deterrence. Unfortunately, the same ice that offered secrecy also posed a constant risk. Stations rested on constantly shifting floes that could crack apart without warning, swallowing runways or splitting camps in two. Blizzards rolled in with little notice, and the cold destroyed machines as easily as it exhausted men. Moving people and equipment in or out was almost impossible, and more than one Soviet crew was forced to flee, leaving behind shelters, instruments, and secrets on the ice. The Arctic was quiet that morning of May 1961, looking just like a white expanse stretching to every horizon. High above it, a U.S. Navy P-2V Neptune, conducting an aeromagnetic survey, traced its monthly route across the pole, instruments droning as they collected readings to chart the shifting ice. Then, through the mist, the crowd spotted something that didn't belong. A cluster of metal frames, sagging tents, and broken antenna masts carved into the snow. The little airstrip that once fed men and supplies lay crushed and buckled by pressure ridges. Ice that had folded and collided like tectonic plates. Whoever had lived there had left in a hurry. The crew of the Neptune had just rediscovered the abandoned Soviet drift station, North Pole 9. The sighting was logged and relayed back to Virginia, where an analyst at the Office of Naval Research, or ONR, began reviewing it. For months, the Navy had been testing acoustic sensors and underwater microphones to study how sound moves through the Arctic Ocean in an effort to track what radar couldn't see. Now, with Cold War tensions peaking after the Bay of Pigs disaster, Washington was desperate for a breakthrough. NP9 looked like what they were looking for. If the Soviets had abandoned it in a hurry, they might have left behind valuable equipment, revealing how far their polar research and surveillance had advanced. It could be the first honest look at what Moscow had been listening for. The opportunity, however, came with a problem. NP9 was far beyond the reach of any ship, cut off by hundreds of miles of dense, drifting ice. Helicopters couldn't make the trip without running out of fuel, and the floe's broken airstrip made landing a transport plane almost sure to end in disaster. Getting in would be hard enough. Getting out might be impossible. Whatever the mission uncovered, extraction would have to happen without ever setting down on the ice. The ONR had the motivation and the manpower, but not the means. So they turned to an agency that specialized in doing the impossible. The Central Intelligence Agency, through its technical research branch, had been quietly funding a handful of inventors to solve the problem of how to extract people or equipment from places where no aircraft could land. Among those inventors was Robert Edison Fulton Jr., a restless engineer who had already worked for the Navy. During the war, he built the Navy's first fixed gunnery trainer, the gun airstructor, and after it designed the amphibian. This two-seater automobile can easily be converted from a car to a plane and back. When the CIA approached him, Fulton revisited an old wartime concept and set out to reinvent it for the jet age. Back in the 1930s, a small mail service in Delaware called All American Aviation had developed a way to pick up mail bags from the ground without landing. The system used two steel poles, spaced 6 meters apart, with a rope looped between them. A low-flying aircraft, trailing a hook connected to a powered winch, would swoop past and snag the line. The winch then reeled in the mailbag as the plane kept flying. On May 12, 1939, All American Aviation successfully tested the system along the Appalachian Mountains, using a Stinson SR-10C to retrieve postal bags from remote towns without airfields. As America prepared for World War II, the method was adapted to recover assault gliders from the battlefield, since each was worth nearly $15,000. In September 1941, engineers at Wright Field, Ohio, demonstrated this new glider snatch system using a modified Stinson to lift a 230-kilogram glider into the air. With the winch-controlled cable to soften the jolt, even fragile craft could be recovered safely. By 1942, the system was fitted to C-47 Skytrains, which used it to retrieve gliders in Europe and later to evacuate wounded personnel across the Pacific. However, for it to work as intended, conditions had to be near perfect. It needed open fields, clear weather, and low, steady flight. Furthermore, the poles and line had to be set up by hand, making it useless in rough terrain or when the air was unpredictable. In the Arctic, those luxuries didn't exist. If anyone was going to make aerial recovery practical, it had to be reinvented from scratch. Fulton studied the old mail retrieval system and saw something that could be improved. The problem, as he saw it, was its dependence on the ground. If the line could be lifted rather than anchored, the system could operate anywhere on Earth. His solution was to replace the poles with a balloon and let the system rise on its own. To make it work anywhere, Fulton designed a compact kit that could be dropped from the air, which included a canvas pack that unfolded into a 150-meter nylon line, a bright orange harness, and a self-inflating helium balloon. Once inflated, the balloon carried the line high into the air, standing out against the landscape like a bright signal. Moments later, a low-flying aircraft, fitted with V-shaped steel horns on its nose, swept past to catch the line. As the cable snapped taut, a small breakaway cord released the balloon, letting it drift free while the winch began reeling in the load. Inside the plane, deflector wires guided the line safely past the propellers, while a powered winch took over, slowly pulling it in to absorb the shock. Within 6 minutes, the person or cargo would be reeled aboard and secured inside the aircraft. Fulton tested his invention in stages. At first, he used sandbags weighted to mimic a person's mass, timing the moment the aircraft's hook caught the line and measuring the impact force. When the bags returned intact, he moved on to instrumented dummies equipped with sensors to measure G-forces during pickup. The readings were high, but within the limits of what a person could endure. Next came the living trials. Fulton turned to pigs, whose size and cardiovascular system made them ideal stand-ins for humans. One unfortunate pig was caught too hard and briefly strangled by the tow line. Others were jerked off the ground, spinning wildly behind the aircraft before being hauled aboard in a state of furious dizziness. The data showed acceleration peaks of 7 to 9 Gs, enough to throw a man off balance, but not to cause life-threatening injuries. After refining the winch payout and the angle of approach, the pickups became smoother. The pigs began arriving calm enough for handlers to approach without needing a lasso. The system could now snatch a living creature from the ground at over 120 miles per hour without breaking bones or losing the payload. Only then did he call for human volunteers. In August 1958, Staff Sergeant Levi W. Woods of the Marine Corps stood on a Maryland test range, strapped into the harness and waiting beneath the rising balloon. A modified B-17 Flying Fortress came in low at 125 miles per hour. The horns caught the line, the cable snapped tight, and in seconds, Woods was airborne, swinging through the sky. 6 minutes later, he was inside the plane, alive, shaken, and grinning. Observers from the ONR and the CIA's technical branch watched from the ground. What they saw convinced them the system worked. Fulton had turned a clumsy wartime gimmick into a precision tool for rescue, espionage, and recovery anywhere on Earth. Major James Smith and Lieutenant Leonard Leshak spent weeks learning how not to succumb to the Arctic. Smith was an Air Force paratrooper and Russian linguist, veteran of high-altitude jumps who'd served with Arctic research teams on T3, the American drift station. Leshak was a Navy geophysicist and studied ice acoustics and knew precisely which Soviet secrets might be frozen out there. Their training took place in mid-1961 at Edwin Air Force Base, where the Navy and CIA were jointly testing Fulton's newly refined pickup gear. Fulton himself supervised the trials. The men practiced everything, from parachute drops and rigging equipment meant to withstand polar conditions, to equipment retrieval, and most terrifyingly, the pickup itself. The most important lesson was mastering the posture. The first man hooked by skyhook, Staff Sergeant Levi Woods, had nearly blacked out when the initial jerk yanked him upright, compressing his spine and cutting off circulation. Fulton had since refined the harness and developed a recovery stance to prevent serious injury. Just before pickup, Smith and Leshak stood with feet spread shoulder-width apart, knees slightly bent, and torso leaned forward at about 30 degrees. The harness, a lattice of webbing across the chest and thighs, spread the force through their hips and shoulders rather than through their necks. Their arms had to be tightly crossed over their chests to keep from flailing, while their elbows needed to be tucked in to prevent dislocation. When the line went taut at 120 miles per hour, the body experienced a sudden horizontal acceleration, strong enough to snap a spine or tear shoulder joints if absorbed unevenly. The forward lean and bent knees worked like shock absorbers, turning the hit into a swing instead of a whip crack. If they braced too stiffly, the harness would drive into the chest and restrict breathing. Too loosely, and they'd spin uncontrollably before the winch could catch up. Timing was everything. At the last second, they were to exhale sharply and tense their muscles, but not lock them. By the end of training, both could set up a skyhook in minutes and ride the extraction without blacking out. The Navy finally had the tool it needed, and NP-9 was the perfect target. 2 men would depart from the U.S. Air Base at Thule, northern Greenland, fly nearly 1,000 kilometers north, and parachute onto the ice near the abandoned station. They would scavenge what the Soviets had left behind, then signal for a B-17 Flying Fortress equipped with the skyhook system to snatch them from the ice. It would be the first time the technology was used in the field. As the details reached Senior Navy Command, enthusiasm gave way to hesitation. Dropping a team onto a drifting floe, with no way to retrieve them if anything failed, bordered on recklessness. The plan sat in review for weeks, and by the time it was approved, it was already late September. Winter was closing in fast. To prepare, the skyhook gear was sent to Edwin Air Force Base in Florida, where it underwent simulated cold weather trials in temperature-controlled chambers. Almost immediately, flaws appeared. The helium balloons cracked in freezing air, winch motors seized, nylon lines stiffened and snapped under tension. Fixing those issues took weeks, and while engineers worked, NP-9 kept drifting northward, farther from Thule. By the time the system was ready, the station had vanished into the pack ice. With no target left, the mission was shelved and its funding withdrawn. Then, in March 1962, new intelligence arrived. Another Soviet drift station, NP-8, had been abandoned after a pressure ridge split its airstrip in two. It was newer, larger, and far more accessible. With Canada's approval, the American staged from Resolute Bay, about 1,000 kilometers away. Through March and April, Reconnaissance flights searched for NP-8, but storms and navigation errors forced every mission to turn back. At last, on May 4th, a patrol sighted it adrift and intact, identified by a large tractor half buried in snow. When the sighting was finally reported, the project's earlier funding had already been exhausted. What remained of ONR's effort had been running on borrowed resources and goodwill. With no budget left to act, the operation was halted once more. The CIA, however, wasn't finished. Seeing the intelligence potential and already invested in Robert Fulton's Skyhook, the agency's Directorate of Science and Technology stepped in to take over. When William R. Jordan answered the phone in mid-May 1962, the voice on the other end said only that the Navy needed a polar navigator for some, quote, Arctic gear tests. He said yes before realizing what that meant. Days later, he was in a San Francisco hotel meeting Robert Fulton, as well as Connie Segrist and Doug Price, both veteran pilots of covert flights. Only after takeoff did Fulton tell him the truth. They weren't going to Tool, Greenland, as briefed. They were bound for Point Barrow, Alaska, to find a Soviet ice station drifting somewhere beyond the top of the world. Jordan just grinned and said he was in. Launching from international territory would have meant days of diplomatic clearance and unwanted attention, something the CIA couldn't afford. At Point Barrow, the CIA's Intermountain Aviation, operating under the guise of a private outfit, ran the show. On the metal runway sat their Skyhook-equipped B-17 and a C-46 Commando, loaded with spare parts and fuel drums. On May 27th, they launched their first search flight. The B-17 was so overloaded with fuel that it needed nearly the entire 4,000-foot runway to get airborne. The flight went on forever. At 8,000 feet, the B-17 traced square search patterns, first at 10-mile intervals, then 5. Below them, the Arctic stretched endlessly in every direction, a flat sheet of gray and white that made no distinction between sky and ground. There was no night, no stars, and the magnetic compass spun uselessly near the pole. The sun never set, erasing the celestial markers he usually relied on for navigation. He had to use the sextant to sight the sun every 20 minutes, plotting invisible lines across an ocean of white in an effort to guide them. Later, he'd describe it as, quote, flying in a void. 13 hours later, they limped back to Point Barrow, tanks nearly dry, and no sign of NP-8. The next day was more of the same. White horizon, white ice, radio static, and long hours of silence. Some began to think the station had broken apart or sunk beneath the pack. On the third day, a Navy P-2V Neptune joined the search. Its radar, far more powerful than the B-17's, swept the ice for hours before catching a faint metallic echo. As they approached, they saw the same tractor, half buried in snow, still marking the site. In the bomb bay, Major James Smith and Lieutenant Leonard Leshak were already strapped in, chutes ready. A Navy doctor, waiting to jump if the insertion went wrong, stood by the hatch. When the doors opened, Arctic wind screamed through the fuselage. They jumped clean, with the insertion going smoothly and without injury. The P-2V soon had to turn back for Point Barrow, while the B-17 made one last pass, dropping equipment crates and a radio beacon to mark the site. The beacon worked long enough for them to confirm his signal. When James Smith and Leonard Leshak hit the ice, the world went silent. The fog swallowed their parachutes almost as soon as they opened, and the sound of the B-17's engines faded into the Arctic wind. Beneath them, the partly collapsed remains of NP-8 stretched. The men had 72 hours to do their work before the ice moved on. While the B-17 Flying Fortress returned to Point Barrow to have its Skyhook gear recalibrated and to drill extraction runs, Smith and Leshak began cataloging everything the Soviets had left behind. At the same time, the P-2V Neptune, the only aircraft capable of tracking the radio beacon the men had dropped, was grounded at Point Barrow with engine trouble. The Arctic cold had thickened its oil and strained one of its superchargers, a common failure in those conditions. For 2 days, there were no radar eyes over the ice. Inside the Soviet huts, they found acoustic instruments, likely used for submarine detection, stacks of radio and radar gear, oceanographic sensors, and film canisters marked with Cyrillic script. They recovered logbooks and notebooks detailing months of weather and magnetic data, along with hints of research into how sound traveled beneath the polar ice. They photographed everything, packed what they could, and marked a pickup zone within a patch of relatively flat ice, cleared by shovel and flagged with a red dye. When exhaustion hit, they slept in shifts inside a sagging Soviet tent that creaked and shuddered with each groan of the floe. The ice beneath them popped and split like a living thing. Back at Point Barrow, the mission's secrecy began to fray. A local airfield worker, a part-time reporter for Time Life, noticed the movement at the base. He started asking questions, wanting to know what the big silver plane was doing, why it had those twin prongs jutting from its nose, and why men in flight suits were coming and going at odd hours. The crew fended him off with a story about conducting, quote, a gravity survey for the Navy and testing new instruments to measure polar drift. When he pressed again after a practice pickup, they clarified they were testing new rescue equipment for downed pilots. The reporter left, skeptical but unconvinced. Meanwhile, the crew turned to more pressing concerns. A low ceiling hung over the Arctic that week, consisting of a 1,000-foot overcast that blurred the horizon and smothered visibility. As the crew began searching for the drifting station to recover Smith and Leshak, Jordan had the pilots fly at right angles to the sun so he could take a rapid series of celestial readings through the haze. In the cramped glass nose of the B-17, he shot 6 sun lines in quick succession and plotted them across his chart. 4 of the lines intersected neatly, while 2 fell wide and were discarded. NP-8 had drifted from the position the Navy's P-2V Neptune had last reported. Jordan's calculations showed that the station was moving slowly westward with the pack ice, sliding farther from the drop site. This turned into another long, frustrating day. The crew returned to the position Jordan's sun lines indicated and began another square pattern search, methodically sweeping the same grid again and again. The radio beacon that Smith and Leshak had dropped was silent, and a persistent undercast hid the ice completely. Jordan hoped that if one of them heard them overhead, he'd burn something, maybe old tires, to send a column of smoke through the clouds, but nothing appeared. They kept searching as long as the fuel allowed, straining for any sign of movement. Finally, running low, the pilots turned the B-17 back toward Point Barrow, the crew exhausted and silent. By the time they landed, there was at least one piece of good news. A replacement P-2V Neptune from Kodiak had arrived with spare parts, and the grounded aircraft was finally repaired. That meant radar eyes over the ice once more, and a second chance to bring the men home. On June 2, 1962, the P-2V Neptune took off first from Point Barrow. 2 hours later, the B-17 followed. Navigator William R. Jordan hunched in the glass nose, his chart spread tight against the vibration. 90 minutes into the flight, a burst of static broke over the radio. The Neptune, now far ahead over the ice, was calling in. Its radar had caught a faint metallic return, and its direction-finding gear had finally locked onto the weak pulse of the beacon Smith and Leshak had dropped days earlier. The coordinates came through. Jordan plotted them, frowned, and recalculated. The position was nearly 70 miles southeast of where his own sun fixes had placed NP-8. After checking the bearings again, he gave the pilots a new heading. Below the gray ceiling of clouds, the weather hadn't improved. Heavy winds scoured the ice, and the fog smothered the horizon as Leshak and Smith braced against the groaning floe, readying the skyhook rig for extraction. Their cargo, a canvas bag stuffed with Soviet gear, film, and hydroacoustic samples, was clipped into the pickup harness. They inflated the silver Mylar balloon and held fast to the tether line, waiting for the B-17. Above them, pilot Connie Segrist felt the world below was invisible until the last seconds of the run. The balloon's bright reflection was the only thing he could see to line up the pass. The horn struck clean. The line snapped tight, and the canvas bag rocketed into the sky, disappearing into the clouds. Seconds later, a winch began to reel it in. With the cargo safely aboard, Segrist banked wide and set up for the next pass. Leshak went first. He crouched into the practice skyhook stance, but the wind tore at him, shoving him across the ice. Every few seconds, he skidded sideways, fighting to stay upright. He tried to dig in his heels, then dropped to his knees, using his elbows to anchor himself. As he did so, the B-17 swept in low, and its horn struck. The line snapped tight, jerking him skyward before he could brace. He spun once, twice, then leveled out into a diver's pose, riding the wind until the winch reeled him home. It took nearly 7 minutes to pull him aboard. Smith watched him disappear into the gray, then unpacked the final skyhook kit. As he strapped in, the wind began to drag him too. He jammed his boot into a crack in the ice, locking himself in place. He radioed up, saying, quote, "Take your time. I'm lying here relaxing in the snow. First time I've been able to relax in a week." Moments later, the horns caught, and the line snapped tight. The radio burst with Smith's voice, asking them not to drop him. Jordan answered through the static, assuring him they wouldn't, though the wind roar made it impossible for Smith to hear. Johnson stayed at his station, resetting the gyro and shooting one last sunline for the return leg. By the time he went aft, both men were aboard. In the cabin, Robert Fulton and Captain Cadwallader waited with a bottle of Johnny Walker Red, toasting the two frozen explorers who had just flown out of the Arctic. Leshak slapped Jordan's shoulder, telling him he knew he'd find them. Jordan smiled, exhausted, answering, quote, "There were times I wasn't so sure." When they landed back at Point Barrow, the airstrip erupted in cheers. Trucks swarmed the plane as soon as its props wound down. Dr. Max Brewer, head of the Arctic Research Laboratory, had prepared a complete celebration in the base library, featuring tables laden with food, trays of hors d'oeuvres, and bottles of whiskey and gin. After the party, the crew stumbled back to their Quonset huts and slept. The next morning, their Arctic gear was gone, and their bags were already packed. It was clear someone wanted them moving fast. After a quick meal, they were bundled out of Point Barrow, heading south for Fairbanks. The haul went straight to CIA and Office of Naval Research analysts. Over the following weeks, technicians cataloged everything Smith and Leshak had brought out. They revealed the Soviets had been running long-term acoustic surveillance, far more sophisticated than Washington expected. The CIA summary later described the operation as, quote, "a very great value," praising the coordination between pilots, crew, and field officers, and proving that Fulton's skyhook system could work in the most hostile terrain on Earth. It worked precisely as he had promised. Within months, the agency expanded the program, building new skyhook-equipped aircraft under the banner of its proprietary companies, Intermountain Aviation, Air America, and later Southern Air Transport. Throughout the 1960s and 70s, the skyhook provided service worldwide. It was used to lift film canisters from surveillance balloons, retrieve downed operatives in Southeast Asia, and most famously, to extract 2 agents and a defecting Soviet radar technician from the Congo in 1966. Even Hollywood caught on. In 1965, the James Bond film Thunderball showcased the system in its closing scene. Decades later, when researchers filed FOIA requests regarding the operation, the release included only a brief report, a few faded photographs, and a note that a painting of the mission, depicting a silver balloon rising from the ice into the waiting jaws of a B-17, now hung in the CIA art gallery. The technical data and most of the recovered intelligence remain classified.